can you name these organic molecules? Let's apply the IUPAC rules to name these molecules. The first molecule here is a branched hydrocarbon chain, and we would need at the beginning to identify the longest carbon chain. So let's follow that with the red color. So we're gonna start from here. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the longest chain, the longest carbon chain, and the parent name here is going to be decane. Decane means 10 carbon atoms. So the parent name is decane. And then let's look at the different substituents that we have. We have this methyl, we have an ethyl here, and we have this one, which is propyl group, which is making the link at carbon number 2. We call this isopropyl. So now let's give the chain numbering. So should we start from the right or from the left? We would need to start numbering from the side that will give the different substituents the lowest possible number. And to do that, we would start from the left. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we would need to look at the different substituents, where their position, and then put them in alphabetical order. So we have the ethyl, we have methyls, and we have isopropyl. So we're going to start off with the ethyl to arrange them in alphabetical order. So the final name would start with the ethyl. So we're going to have 5 ethyl, and then we're going to put the isopropyl, so 7 isopropyl. And then we're going to put the methyl. We have 2, 3 dimethyl. Of course, we're going to ignore the di here, just the methyl. That is going to be accounted for in the alphabetical order. And then finally, decane. Now let's move on to the second one. So the second one is again branched hydrocarbon or branched alkane. And then we need to look at the longest hydrocarbon chain. So let's start from here. 1, 2 carbons, 3, 4, 5, 6. So this is the longest carbon chain. And that means the name where there are 6 carbon atoms, it's called hexane. Now let's look at the different substituents. We have methyl here and another methyl, both of them on the same carbon atom, and then we have a third methyl. Now let's give them the numbers. So we're going to start from the left again, because that will give the substituents the lowest possible number. So 1, 2, 3, 4, 5, and 6. Now our substituents, we have two methyl groups on carbon number 2 and one on carbon number 5. So we have to mention all of that in the name. So it's going to be 2, 2, 5, and then trimethyl, which means 3 methyl groups, and then hexane. Now let's move on to the following one. The following one is an alcohol. And here the alcohol, because it's an alcohol, the OH will take priority. So we're going to always look at the carbon that is attached to the alcohol and try to give it the lowest possible number. Now this carbon here, if we look at the longest hydrocarbon chain as well, so we're going to start with this carbon, which is attached to the OH. So 1, 2, 3, 4. That means the parent name here is 1-butanol. You can also call it butan-1-ol. Both of them are correct. And then the only substituent we have here is this methyl group on carbon number 2. So when we give the numbers to the carbon chain, 1, 2, 3, and 4. So the methyl is on carbon number 2. So the final name here is going to be 2-methyl butan 1-ol. And this is the final compound here. Again, we always start by looking at the longest hydrocarbon chain or the longest carbon chain. So if we start from this carbon here on the left, so there is 1, 2, 3, 4, 5, 6, 7, and 8. So this is the longest carbon chain, and it has 8 carbon atoms, which means the parent name is called octane. So octane means 8 carbon atoms. So it's called octane. This is the parent name. Now let's look at the different substituents. We have this chloro and we have bromo and we have a methyl group as well. So should we start now numbering from the right or from the left? We would start numbering again from the side that will give the different substituent the lowest possible number. So if we start from the right here, so let's say 1, 2, 3, 4, 5, 6, 7, 8. The substituents would be on carbon 3, carbon 4, and carbon 6. But if we start from the left, let's have a look. What would the substituent, which carbon would the substituent be on? So if we do 1, 2, 3, 4, 5, 6, 7, and 8, now the substituents are going to be on carbon 3, carbon 5, and carbon 6. So that means when we do the numbering from the right, then the different substituents will take will take lowest number than when we do it from the left. So we're gonna start the numbering from the right, not from the left. So it's 1, 2, 3, 4, 5, 6, 7, and 8. We have the methyl substituent, we have the bromo, and we have the chloro. And to start by putting them in alphabetical order, we're going to start with the promo. So it's going to be 4 promo, and then the chloro will come next. So 6 chloro, and then we have 3 methyl, and then the final name, which is octane.